So what I'm playing with here is the Teensy 3.1 and the audio module hooked up as a software-defined radio. So there's the Teensy processor module on the top. This white wire is a microphone input, which just actually goes in out of the USB. This is the audio shield. I added a pot to it. The pot is actually what's doing the tuning. So I'll demonstrate that in a sec. The rest of the setup here is I got some jumper wires. I put in some audio transformer isolation because this audio input is coming from over here, which is my SoftRock, and this is the actual crystal, or actually it's an SI570 VFO, which is essentially taking, this is the RF front end clocked by this thing, which is converting the audio down to sort of baseband audio, and then the audio processing is done on the Teensy. So I've hooked up, you can see here a little TFT display, which is doing a spectrum display, and that's TFT is actually running soft SPI, so the hardware SPI is used to interface to the audio module, and I'm just using a soft clocked SPI to interface to this 1.8-inch TFT. So the tuning indicator is the little red part on the display, and as you can see as I move it around, the frequencies change. It's not perfect, it's just a player at this point. So if I tune the pot, you can see the cursor moves and the frequencies change. So I'm listening to 20 meters here. There's a contest on today. Obviously it's really reactive, so it's a good time to test things like this. And so I haven't really got a diagram of what the software is doing here, but basically we have audio going into the Teensy module. There's a software VFO, which is kind of what this is indicating. As I'm tuning the VFO with this pot, the cursor is sliding up and down. That goes into a multiplier module, so it's basically mixing the audio with that VFO, and that converts a section of this band down to another section of audio, and I have a low-pass filter on that. So that's why I'm using CW here, because the low-pass filter cuts off about 1 kilohertz. It's not a really sharp brick wall filter or anything. As you can tell, there's a lot of stuff coming through in CW, but I'm pretty impressed with this Teensy module. It's got a lot of compute power, and the audio module works very well. I should also mention this is a direct conversion. I haven't implemented sideband suppression yet. I've got I think I've got the software pieces in place. I just haven't done it. So this was the first iteration of the thing, just to see if I could get it working. And as you can see here if I fire up the serial monitor, this is telling me what my processor utilization is. It says my processor utilization is 21%, maxed at 22. It's using 5 memory blocks, and the maximum usage was 6 memory blocks. So that's pretty good. So I'm only using about 20% of the CPU to process mono audio and do FFTs, run the TFT display module, do a simple VFO. So I thought this is pretty impressive, actually, for a tiny little microcontroller. So as the VFO frequency, you might notice it's a little bit wobbly. It's because it's tuned with an analog pot. So obviously I'd want to have an encoder or something here in the final implementation, but still works pretty good. But you can hear the tone wobbles a little bit because of the A to D jumping around a bit. So yeah, so this is my first attempt at doing SDR on a microcontroller, and it was remarkably easy with the Teensy and the audio library they supply.